Mature skeletal or striated muscle cells are the longest and most slender muscle fiber, ranging in size from 1 to 50 mm in length and 40 to 50 micrometers in diameter. Because of this unique structure of the cell, that is, their length being much greater than their width, skeletal muscle cells are often referred to as skeletal muscle fiber. In addition, each muscle cell or fiber is multinucleated and is surrounded by a special cell membrane. This cell membrane is electrically polarized and is called a. The sarcolemma is surrounded by the first of three types of connective tissue found in the muscle, the which is delicate connective tissue. Each individual bundle of muscle cells, or fascicle, is surrounded by another layer of connective tissue called the perimysium. This is visible to the naked eye. This perimysium connects with the coarse irregular connective tissue that surrounds the whole muscle called the epimysium. When skeletal muscle is viewed under a microscope, the cells appear to have alternating dark and light bands referred to as cross striations. These striations are due to an overlapping of the dark and light bands of protein on the myofibrils. The number of other markings are important to note. The narrow, dark staining band found in the central region of the eye band that looks like the series of the letters Z one on top of another is called the Z-line. A slightly darker section in the middle of the dark band is called the H-band or H-zone. This is where the myosin filaments are thickest and where there are no cross bridges on the myosin filaments. All of the muscle cells or fibers innervated by one motor neuron are called the motor unit because they are always excited simultaneously and therefore contract together. It is important to remember that the terminal divisions or axon endings of a motor neuron are distributed throughout the belly of the whole muscle. Stimulation of a single motor unit causes weak but steady contractions in a broad area of the muscle rather than a strong contraction at one tiny specific point. As the nerve impulse reaches the neuromuscular junction where the axon terminals of the nerve cell are in close proximity to the muscle and its numerous cells, it triggers the axon terminals to release a neurotransmitter substance called acetylcholine. Is chemical substance FECDs the muscle cell membrane. It causes the sodium ions which were kept outside during the resting potential to rush inside the muscle cell, TH is rapid inflection index of sodium ions creates an electrical potential that travels in both directions along the muscle cell at a rate of 5 meters per second. TH is inflection index of that causes the inside of the cell to go from being electrically negative to being positive. TH is a signal to the muscle cell to generate its own impulse called the action potential. TH is the signal to contract. Meanwhile, the potassium ions that were kept inside begin to move to the outside to restore the resting potential, but they cannot change back to the resting potential situation because so many sodium ions are rushing in. This rapid influx of sodium ions creates an electrical potential that travels in both directions along the muscle cell at a rate of 5 meters per second. This influx of net causes the inside of the cell to go from being electrically negative to being positive. TH is a signal to the muscle cell to generate its own impulse called the action potential. TH is the signal to contract. Meanwhile, the potassium ions that were kept inside begin to move to the outside to restore the resting potential, but they cannot change back to the resting potential situation because so many sodium ions are rushing in. TH release of the calcium ions from the sarcoplasmic reticulum inhibits the activity of the troponin and the tropomyosin, which have kept the actin and myosin myofilaments apart. TH calcium ions attach to the troponin and now cause the myosin to become activated myosin. TH myosin filaments have large heads that contain ADP molecules. TH activated myosin releases the energy from the ADP at the actin active site when the myosin links up and forms actin-myosin. TH head linkage makes a cross bridge that pulls the actin filaments inward among the myosin filaments and breaks down the ADP into adenosine diphosphate.